Hi, I'm going to show you a little bit of how I've been playing around, trying to read some oceanographic data. These are old data referred to in this document, the Stalcup document there. This is a Zotero window, and I'm going to show you three windows. One is a Zotero window, another is an editor window in which I'm running R, and a third is like a graphical window, which I'll show our results. Okay, so basically, I've downloaded this document here, the Stalker document, and I'm looking at a particular page here. I'm interested in station 61. That's on page 226 of the document. And I guess this is the 226 is the sort of PDF page number. The printed page number is 215 in the document. Okay, so there's two portions here. These are clearly data portions. This is giving the location. This is kind of a queer format that oceanography geography type people use, which is 36 and then a space. Okay, this document is from quite a long time ago, and the computers weren't able to make a degree sign then, I don't think. So you can see here, this is meter cube, but they can't do that either. And here they're using degrees. So anyways, I think this is 36 degrees, 40 minutes north, and this is longitudes, etc. Okay, so if you look at this, PR is the pressure in decibars, and this looks like a DF. I think it's a DE for the depth in meters. Let's see, this is N in cycles per hour, but I'm going to skip that, and I'm going to skip, that's probably dynamic height. Skipping, we can compute these. Skipping, okay, oxygen is fascinating, but I'm not going to, I don't care just for the moment. Okay, so first I want you to look at these pressures. They're kind of uniform, apart from the first, like they're at discrete intervals, like 100, 150, and so on. But there's a funny one, 3, and then at the bottom. So I think what they've done is they're giving you the very top and the very bottom of their measurements. And in between they have, okay, I don't know what they've done, interpolated or somehow, somehow, well, I'll say interpolated. Okay, and I think the bottom one must be the actual data. And it says that these are CTD, but I don't really understand this. I honestly don't see why the CTD would only be recording at these depths. So, I don't know, maybe these are bottles. That's a heck of a lot of bottles, but maybe it's probably bottles. I really want CTD, so this is kind of a waste of time what I'm doing, but might be an interesting video. Okay, so here, what do we have here? Over here are depths. I'm going to read these 104, 102, 208. Okay. Now I'll show you another window, and I found data for this. And this is the top window here. Can you see I'm doing something so you can see the top and bottom of that? Okay. Let's see, we'll go into this one now. Okay, so I believe this means station 61. And let's just have a quick look in this. So I see a number 15 and then a number 102. Let's just go back to this baby. 15, well, 14, I think it's just rounded. And then 10, it's hard for me to read this, but I think that's 102, 208, 312, I think. Okay, so 15, that was the 14, 102. So clearly this thing here is giving the depth in meters. That's fine. And then we see a number here, 26629, and then a 3. I believe this is temperature, and I believe the 3 is a quality flag, 3 meaning good. So I'm reading it as 26629. I believe that means a temperature of 26.629. So let's see if we find that, 26.629. Well, that's good. And then the next would be salinity, and I'm seeing here 36145. 36145, and then a 3. Okay, so I believe that I can now read the depth, the salinity, and the pressure. And I bet this is oxygen here. Maybe I have a quick look at that. 4. Oh God, it's a challenge for my eyes. I can't. I think that says 468. I'm not completely sure what it says. So that would be the 468. Oh, they're both 468. Okay. 468. Okay, so I don't know. I don't know what that is. Sorry, I'm over here. 4, 6, 7. Could that be a 7? Was the next 473? 474? Okay, I don't know, there's rounding or something, but I'm pretty sure that must be oxygen. And the others, I don't know, nitrates, etc. It's all fascinating and it would be good to read. Now going back to this is clearly a header line. And I see an N here and I see 3640. Test of your memory, 3640. Okay, good. So the lons and lets seem to be combined or contained in the third token on that line. EV, I bet you means Endeavor. That's the name of the ship. Eh? Okay, I'm going to call this it looks like two header lines. This one here, and which I think gives cruise information, and this one which gives, I'm assuming, station information. How to recognize them. One is I noticed this column over here, and it's like ones and twos and whatnot. And I think that could be a way to recognize those columns. Sorry, those rows, those header rows. I mean, that would be a good way. I just noticed that now. I actually have some code, and let me just show you the code that I've written. So it's in the R language. And so first I load up a library, OCE. Then I've got the URL. You could pause the video and you could write down that URL if you wanted to. And then I'm constructing a file name from that. And I'm saying if I don't already have the file downloaded, that's so I can run it over and over and without re-downloading. Here I read the data. Here I'm finding, yes, so I guess what I'm thinking is I was looking for a zero space. So now I'm going to look for what is it, a $1. Okay, so that's fine. We'll see if that works. And then what I'm doing here is making a data frame and it's got okay, so this is in R. If you know R, you can understand what I'm doing with the head with negative argument and a tail with negative argument. What I'm doing here is I'm saying, okay, between lines 3 and whatever, 15 or something, that's where the data are for that. And then I'm going to get a bunch of chunks, asking for space for chunks. I'm going to read them all in. And I happen to know that chunk 6 is the one I want. I'm grabbing here the data portion. I'm skipping the 2 lines at the start. I'm having a look at the data portion. Now what I'm doing is I'm grabbing out, now these are in a format that's clearly designed sort of in the old days. And now you would separate things by commas or spaces. And here it's fixed format, right? So this is column whatever. That's column 1, 2, 3. You count by 0, but the computer 1, 2, 3, 4, 5, etc. And I've just done that. That's all I've done. Columns 1 to 5 is that. And I'm grabbing the depth, I'm grabbing the temperature, I'm grabbing the temperature flag. And this is all just hypothetical, but let me just run it. Let's see here. Where are we? I'm not sure what that window was down there. Okay, so, right. So let's see. So I'm right here, I'm doing a summary. Sorry, I'm doing a summary and I'll just run that line again. Doing a summary. And so you can see the data. So it's giving, and these look like reasonable numbers. Okay, so what I'm going to do now is I'm going to stop sharing that and I'm going to share the so-called quartz window that gets created. And so this is a TS diagram from that. And now I'm only showing one window. I don't know how when you stop sharing, you can add it to 2 things, but I'm going to redo, this is a summary plot and of the whole thing. Right. So here's these are profiles. See, this is pressure here. It's 4 kilometers deep. It's like real ocean data here. This is the surface, and this is like 4 and some kilometers deep. I'm going to call this color red if you're colorblind, this one. And I'm calling this color green if you're colorblind. But I'm pointing here at the temperature curve. These look like reasonable numbers. I mean, I know that I'm not reading garbage here. And I'm going to call this color blue and tracing the blue line here. This is density. And this other color, which is like a brick red, I'll call it, is for the square of the buoyancy frequency, which should be high and then low and then high and then low. And this bottom one is a temperature salinity graph or diagram, which again has a character that I would expect to see. Right, so I think this is the end of the video. So what I next have to do is to go back in the header lines and decode them to get longitudes and latitudes, station numbers, and all this other kind of stuff. And I guess I could also try to find what the other columns are, like if one of them is silicate and so forth. But halfway along to having maybe 50 lines of code that could read this format. It might be useful, and therefore it might be something that would be good to put into the OCE package, but I'll talk with my collaborators on that package, Clark Richards and Chantal Layton, and see if they think it would be useful, because OCE is big, and the more stuff that gets added to it, the more stuff has to be maintained and so forth. And OCE has lived for 10, 15 years at this stage, and I've never tried to read data like this before, which kind of says maybe this is a data format that we can skip. Honestly, to be brutally honest, it's also possible OCE already reads this data format. I don't usually check such things. I usually find it's just as easy to spend 5 minutes writing some code to try. That's the end of the video. Greetings from a rainy Halifax that is soon going to be a freezing rainy Halifax, I believe. So take care. Bye.